Mark?
Yes, do you hear me?
Yes, yes.
Yes.
Perfect.
Okay. Okay. You see my, can you see my screen?
It is empty right now. Now, perfect.
Okay. So, thank you for attending this session. I will present safety and security co-analysis with safety architect. And when I talk about safety and security co-analysis, I don't speak about co-engineering. For co-analysis, I mean how we can reuse security artifacts to do a co-analysis in safety architect. Um, so safety architect is Alphotech commercial tool, um, initially dedicated to support classical safety analysis method like failure mode analysis or fault tree analysis. And um, for the presentation, I will present the different feature of the tool. For example, there are 6 main features in the tool. You can import a model from different modeling tool like Papyrus or Capella or IBM Rapsody. And thanks to the series modeler, you can also model in the tool. And what is interesting in this presentation is the local analysis of the different elements of your model. So I will take a small time here to see how we can do safety and security co-analysis in different models. And then from this analysis, you can generate your propagation tree, and you can do some report like FMECA table, and you can also export the fault tree generated in Safety Architect to other fault tree tools. So let's go directly in the tool to see the demo. Okay, do you see Safety Architect tool 3.0?
Yes.
Yeah, okay. Um, so as I say, in the tool you can model directly in the tool, or you can import model from different modeling tool. For example, here I will import a basic model. For example, you can import Magic Do, Papyrus, Rhapsody, IBM System Architect, or Safety Architect model, of course. For example, here I will import a small example, a fire detector example. Quickly. Okay. So tool import. The tool. When you create your model in Safety Architect, it is an Eclipse-based tool. You have 3 files. You have the .ird, which represents the graphical representation of your model, and you have .sar, which is the different element of your model. And you are also the .fear event, which where you can create your fear event. For example, if you identify some fear event in your primary hazard analysis, you can define this fear event here. For example, for the example I define, for example, the fear event fire for the fire detector example. Okay, and in this context, we have to do some analysis to see how we can see the safety and security artifacts which can impact this fear event. So let's open an example. In Safety Architect, everything is a viewpoint, so the tool is based on the concept of viewpoint according to software and system architect standard. So the first viewpoint is the system modeling viewpoint. And in this viewpoint, you have, it is a gray box. You have the system, an input port, and the output port. And for example, for this example, the fire detector example, you have, for example, the data we can be the smoke of the fire, and you can have a parameter, the threshold parameter. According to this threshold parameter, the system can trigger a sprinkler or an alarm. Okay, and this is the high level of the system. And the next level is the system architectural viewpoint, where you describe the exchange between the system elements. For example, here everything is typed in Safety Architect. In the green, you have a function. So let's the function of your system. For example, here you have the data acquisition function and the data processing function. And you can allocate your function in logical component. Here it is the software component. And you can also allocate your function or logical component to physical component. Here, for example, the hardware component processor. So this is a basic example to show how you can do safety and security co-analysis. So to do that, you have to select your viewpoint. For example, here you can select the safety and security viewpoint to do the analysis. For example, here I select the architecture, safety, and security viewpoint. And let's consider now the safety viewpoint of the data processing example. For example, here you can create safety and security viewpoint for the different elements. I already done this analysis, so I will open first the safety viewpoint of the data processing function. For example, in this function, we have different elements. When you open your safety viewpoint, the input and the output port is annotated with the failure mode. For example, here you can add a predefined failure mode, for example, absent, intempestive, erroneous, and you can add also specific failure mode to define your specific failure mode. For example, here I can name this specific loss of the sprinkler. Okay, and now you can begin the analysis of your element, the function. And to do the analysis, the first, I can hide, for example, here. First, I say that to have the erroneous of this output, you have to have the erroneous of the input, the data, or the erroneous of the parameter. And in this failure mode, you can associate also the cause of your failure or the failure detection. For example, here I say, for example, the verification of data. You can also consider the allocation relation. For example, here I say that if the component on which the function is allocated is failure, I can have the failure of this function. And the next thing important to annotate is the notion of barrier. And this concept is used to mitigate the propagation of failure in the element. For example, here I had a barrier named a watchdog barrier, and I say that to have the propagation of the failure, you have to have the failure of this barrier. So you can add also a failure mode in this barrier to see, for example, the cause of this failure mode can be the implementation error. So here it is the safety viewpoint in this function, and you can have also okay. You can have also the safety viewpoint of software or hardware component. For example, here I show you the safety viewpoint of this component. For example, I say here, if the component, the hardware component is erroneous, my software component is also erroneous. I can do the same analysis in the hardware component. For example, here in the hardware component, you can have the internal failure of your component, and you can define the probability of failure of this component. For example, you have a predefined probability function. You can use it then and define your probability of failure of this hardware component. This is the safety viewpoint, for example, of the element. Let's consider now the security viewpoint of the element. But in the security viewpoint, I will consider, for example, here the data acquisition, which is allocated in the sensor. And this function is allocated in the sensor. And in this example, we can consider that the sensor are more vulnerability than other elements of the system. So for example, here I open the security viewpoint of this element. And in the security viewpoint, you have different elements where you the artifact of security. For example, here I define the vulnerability mode of the input. I say that from, for example, vulnerability analysis, which can be done in another tool. For example, we have another tool named Cyber Architect. In Cyber Architect, you can do your security analysis. So you can reuse this security artifact in Safety Architect to say, for example, here I had a vulnerability mode, and this vulnerability mode can be exploited if there are an assertion, for example, here, if an attacker can manipulate this vulnerability remotely. Okay, and I say also I can add also an operation in my allocation relation to say that in the context of vulnerability and assertion, an attacker can take a control of the sensor to run the remote exploitation attack. All right. So I can go in the sensor now to see how I can do the security analysis. And in this, when you open the sensor, you have already the operation mode and in the allocation relation and the output of this sensor. And so the attacker can take this mode to do an attack. For example, can run the remote exploitation attack in the sensor, or it can modify the kernel of the BIOS. In the context of the in the context of the vulnerability and the assertion of the element. So you see, when I come here, I see, for example, here I can do also the safety analysis of my sensor. This is different. In the safety analysis, I see that the sensor can have the internal failure. And this internal failure can, in this internal failure, you can lose the function, or you can have the failure of the bus. So now I do the analysis of this basic example. So you have the safety and the security viewpoint of the element. So now you can generate the preparation of this failure or this security artifact to see how we can have the failure event. So to do that in Safety Architect, you can just go in global analysis, run propagation, and in the propagation, you can select your viewpoint. For example, here I can select to see the propagation of my failure in the safety viewpoint. So I can just generate the propagation for this failure. For example, here I generate the fault tree for the safety viewpoint. For example, here we see, for example, the propagation tree in the safety viewpoint. I can also generate the propagation in the safety now, which is interesting for the safety and the security viewpoint. So I will generate the propagation of the two artifacts according to the analysis of the safety and the security co-analysis. So I can do next. I will generate the propagation. So, for example, here, this is the propagation of safety and security. And in the propagation, we can see, for example, the security artifact. You have the attacker. We can take the control of the sensor to run the remote exploitation of the data. So, so we can see in this, for example, this tree is different from the safety fault tree. And we can see this an example. You can also export this propagation tree to see the graphical representation in dedicated tool. For example, I will export this fault tree to the OpenPSA format. It is an open standard for fault tree representation. So I will generate this in. I'll take the propagation tree for safety and security. I will put it in my desktop. Next, okay. And if and in App Analyst, I can open the graphical representation of this propagation tree. So we see, for example, here the graphical representation of the propagation tree with the probability of failure of the different elements, and you have also the security artifact.
Mark, sorry for interrupting you. See, the screen is gray. Somehow you're putting one application on top of the desktop. Okay, perfect. Thank you.
Okay. It is clear now?
Yes. You can continue. Sorry.
Now I present, for example, here the graphical representation of safety and security propagation. For example, here we see, for example, the security artifact, for example, the vulnerability of the input, and you also see, for example, the safety artifact, for example, here the internal failure of the processor with the probability of failure of this processor. Okay, right, and what I can also present you, you can also generate the FMECA table. For example, to do that, you can just go in report, and report, For example, I can generate the safety and security report. I can also generate the FMECA report or a general report. Let's take FMECA report, and I will take, for example, the propagation of safety and security, and I will select some elements to report, for example, here. Do you see my screen? I change.
Yes. Perfect.
Yes. Okay. Now we see, for example, the FMECA report from the analysis of the model. For example, here we have the threat of the fire detector, and you have also the safety artifact, for example, the error use of this data. So you have an item, the function, the failure mode, failure cause, and you can also you have the failure detection and the compensation provision. So I think I show you all the methodology of the tool. So to resume, in Safety Architect, you can import model. You can do also modeling in the tool thanks to Cirrus Modeler. You can do local analysis of your element. In local analysis, it is you can do the safety and security analysis. And security analysis, you reuse a security artifact from another tool. And from this local analysis, you can generate your propagation, and you can do the report of this analysis, and you can also export the artifact generated in Safety Architect to a dedicated tool, as I show you in the example. It is all for me. If you do you have a question?
Okay. So thank you, Mark.
Yeah.
Okay. So let's move